far as factoring it, simplifying it, breaking it down, it can't be factored in that way. So, next problem. Let's say we have 4x to the fourth minus 64. Okay, I know that 4 and 64 have something in common. So what I'm going to do is I'm going to factor out a 4. So my question I want to ask myself is what times 4 will give me 64. So when I pull out a 4, I'm left with x to the fourth minus 16. Well, this can be written as x to the fourth minus 4 squared. And so that almost looks like a perfect difference of squares, but the way you can write it is you can write it as x to the second raised to the second again minus 4 squared. So now you have a difference of squares. And what that's going to be is that's going to be x squared minus 4 times x squared plus 4. Now the question you must ask yourself is, am I through with this problem? And the answer is no, because you still have a difference of squares there, because 4 can be written as 2 squared. So this can actually be broken up. So how you write it is you write x plus 2, x minus 2, because this is x squared minus 2 squared, and you still have your x squared plus 4. So this will be your final answer. And sometimes I know it's hard to grasp that something that starts off as just 2 terms ends up as 4 terms being multiplied, but it's very possible. Let's see another magical problem like this. Let's say, for example, we have 1 minus y to the 8th. Well, this is the difference of squares, because this can be written as 1 squared minus y to the 4th power squared. So this is a difference of squares. And so difference of squares by the formula. So difference of squares by the formula will tell us we have 1 minus y to the 4th times a 1 plus y to the 4th. So the question is, are we finished? We're finished with the 1 plus y to the 4th because it has a positive, but we're not finished with the 1 minus. This can actually be written as a 1 squared minus y squared for this piece. So that's the difference of squares in itself, which gives us 1 minus y squared times 1 plus y squared. And don't forget the 1 plus y to the 4th. So you ask yourself, the 1 plus y squared, 1 plus y to the 4th, that's finished. But we still have 1 minus y squared. That can be seen as 1 squared minus y squared. So this by itself can be broken up as 1 minus y times 1 plus y. And then we bring down the other two, which is 1 plus y squared times a 1 plus y to the 4th. So this is the final answer. And you know that it's the final answer because when you look at the 1 minus y, this y is no longer squared or raised to the 4th or even no even power. So therefore, this is the final answer of the whole entire problem. Let's say we're given 16x squared plus 24xy plus 9x squared, 9y squared, my apologies. So it looks kind of difficult because you have x squareds and y squareds and x's running all around. But let's say that when you look at this problem, it could be written as 16x plus 24x plus 9. This can be worked just like this. So the y and the y squared, we'll deal with that later. So right now let's deal with it as it looks right here. So this would be an AC method because we have a number connected to the x squared. And since 9 is 3 times 3, there is a 3 in 24, but there is not a 3 in 16, so you can't factor a 3 out. So you have to multiply 16 times 9. And so what you end up with is 16 times 9, which will give you 144. So what two numbers multiply to give you 144 and add to give you a positive 24? Well, that's 12 and 12. So you have 16x squared plus 12x plus another 12x plus 9. And then you look at each piece. So the 16x squared and 12x, I know an x can come out, and 16 and 12 both share 4. So I can pull a 4x out, and I'm left with x plus 3. And then I look at the 12x and 9 and I can pull a 3 out, and I'm left with the 4x plus 3. So something must not be right. So when I look at this first parenthesis here, 4x times x will give me a 4x squared, but I need a 16x squared, so I'm missing a 4. So it's actually a 4x plus 3 in the first parentheses as well. So since these parentheses match, I can put this together, and I have 4x plus 3, and then I bring down the 4x plus 3 that's in the other two parentheses. And so my answer is 4x plus 3 times 4x plus 3. So if you saw this, it would actually look like a 4x plus 3 to the second power. What if we had a problem like 2 pi r h plus 2 pi r squared? Well, looking at this piece and this piece, they share 2 pi r. So I can pull a 2 pi r out. And what I'm left with is h plus r. And that's as far as you can go with this problem because it's already simplified in its most simplest form. Back to that previous problem we had, it was a 4x plus 3 squared. But we remember that we had y's in the problem, so it actually would be written as 4x plus 3y to the second power. My apologies. So let's look at another one similar to that. Let's say we have 6q squared minus 3q plus 2pq minus p. Well, this is 4 pieces. So it looks like I have a q in every piece except the last piece, so I can't pull a q out. So I can factor this by grouping. So when I look at the first two, I have a q and a 3 in both of them, so I can pull out a 3q. And I'm left with 2q minus 1. And then when I look at this one, I can pull out a p, positive p, and so I'm left with the 2q minus 1 in this one as well. Since these match, I have 3q plus p times a 2q minus 1. This is what's called factor by grouping. So whenever you have 4 terms, you group them in 2's and you factor each one separately. So how about this one? Let's say we have p squared q squared plus 7pq plus 6. This one looks a little weird because it has pq in the same part, but it can also be viewed as just x squared plus 7x plus 6. Don't let all the letters throw you off. So if you was factoring this one, what two numbers multiply to give you 6 and add to give you 7? That's 6 and 1. So the answer would be x plus 6 times x plus 1. It's worked the same way. So because we have x squared and there's an x in each one, if we have pq squared, there'll be a pq in each parentheses. Same difference. And it'll be pq plus 6 times a pq plus 1. And that's pretty much it with that one. So let's look at this last problem. And hopefully after this video you can be more comfortable with factoring. So let's say we have 81 a to the 4th minus b to the 4th. Well, I know that 81 a to the 4th, I have to make this look like the formula a squared minus b squared. So I can make 81 a 9a squared squared, because that will give me 81. 9 squared is 81. A squared squared is a to the 4th minus a b squared squared. So this looks like the formula. So I can write it as 9a squared minus b squared times a 9a squared plus b squared. Again, when you look at the plus, you're fine. You're finished with that part. When you look at the minus, I still have a difference of squares. This parentheses here can be written as a 3a squared minus b squared. So just this part alone can be written as 3a minus b times a 3a plus b. And then you bring down the 9a squared plus b squared. And so when you look at the minus, you have a 3a and a b. They can't be written as squares, so therefore this is your final result. And that is factoring.